Yes.
There's G. Fantastic. So we're going to take a look at a few practice problems involving molar concentration and dilution. For starters, remember we expressed kind of in passing last week that molarity or molar concentration is a handy mathematical way to express how concentrated or dilute a solution is. And you get molarity or molar concentration by taking the number of moles of solute divided by the volume of your solution in liters. Okay, so we're talking fairly simple operation math. One thing I'm going to point out is, and I mentioned this in passing too, anytime you've got three variables that are related, where one equals something divided by something, or one equals something times something, then you can make a magic triangle out of that. So I'm going to put a magic triangle up here, and I might want to do the same. Triangle cut in half, and then cut the bottom half in half again. And what we're going to put on this is we're going to put molar concentration down here. We're going to put moles of solute and I'm going to put volume in liters down here. And just like any magic triangle, the way you use this is you take a look at what the problem is asking you for, and you cover it up and do what the triangle tells you to do. So, case in point, if I want to find what the volume of the solution is, and I know both its molar concentration and how many moles are dissolved in it, then I just cover up what I'm looking for, and it's just going to be moles divided by molarity. Okay? Moles over N. If I'm looking for how many moles are dissolved in the solution, but I know its concentration and I know its volume, then I cover up moles, and it's just going to be concentration times volume, since they're side by side. So we'll start with a few easy ones here. Question 1, it wants to know what's the molarity of 3.7 moles of potassium bromide dissolved in 2 liters of water. So they give me moles, they give me volume in liters. So all I do is do moles divided by liters. So it's going to be 3.7 divided by 2. Which handy calculator tells me I get 1.85. Somebody confirm? Okay. So what are my units? Good question, right? So if this up here is moles, and this down here is liters, then I could express it as moles per liter. Or I could just say 1.85 big M and read it as 1.85 molar. Or you also see sometimes just the number in brackets, and it all means the same thing. So any of those would be fine. Questions? Okay. Let's look at number 3, and yes, I know I can't count. So if a solution starts with 3.75 moles of HCl and has a molarity of 5 molar, what volume was the HCl dissolved in? So here I'm trying to find volume. So I cover up my L, and it's going to be moles divided by molarity, moles divided by concentration. So I'm just going to do 3.75 moles over 5 molar. So 3.75 divided by 5. I get 0.75. What's my units here? Liters. Okay, very good. Okay, so that's easy enough, right? Okay, let's skip a couple. We'll skip 5. We'll skip 7. Let's come down and take a look at number 9. Number 9 throws us a little bit of a curveball, but nothing y'all can't handle. Take a look at 9 and see if you can see the trap.
You need to
careful of those units. They'll get you every time. So in our Kool-Aid lab last week, you were working with 100 milliliter quantities of solution. Remember what that was in liters?
0.1.
0.1, right, or 1/10. So in other words, if I'm going to be converting from milliliters to liters, then I'm going to be dividing by 1,000. I could also say, just as easily, that I'm taking the decimal and I'm moving it that way 3 places. Okay, that's important to kind of keep in mind. So if I change this to liters, which I need to do if I'm going to be doing these calculations, then that would be 0.1 liters. Okay? So it wants to know how many moles. Again, if I'm looking for moles, it's going to be, actually I haven't done one of those yet. It's going to be concentration times volume. So if I take concentration, which is 0.2, times volume, which is 0.1, that's going to give me an answer of 0.02 moles. Not bad so far, right? Does anyone have a question? Okay. Let's dial it up a notch. Let's take a look at number 11. What's the problem in number 11? Why is this not like something we've seen before?
It's asking for grams.
Oh, it's asking for grams. Now, grams aren't even up in any of this mess right here, right? So what do you think I'm going to have to do?
We'll take moles and football to grams.
Exactly. So at some point we're going to have to convert moles into grams. So if you have your molar football, the easiest way to do that is to start pulling from the left. So if I'm converting from moles of a substance into grams of that same substance, which is going to be my last step, then I'm just going to take number of moles times my mole mass. Okay? And that's all that's reminding me of. So I'm going to set that off to the side. And let's see what we're doing here. So we need to make 100 milliliters of a 0.25 molar solution. Is there anything else I need to be aware of here?
You need to switch it to 0.1 liters.
Good. Okay. So if I'm trying to find moles, it's going to be just like I had a minute ago. Moles is equal to concentration times volume. So I'm going to say 0.250 times 0.1. It's going to be 0.025 moles, right? But I need to find the mole mass of CaOH2. What is CaOH2? Ca is calcium. What is OH? It's been a while. Hydroxide. Good job. Okay. So to find the mole mass of calcium hydroxide, where am I going to go? Periodic table. Absolutely right. Okay. So calcium is decently close to 40, and we're, for our purposes, we're going to keep it simple and do some heavy-duty rounding. So calcium is just going to be 40. Oxygen is 16, but I have 2 of them. So 2 oxygens is going to be 32. Same, I've got 2 hydrogens. Hydrogen is 1, but there's 2 of them, so that's just going to be 2. So 40 plus 32 plus 2, 74 grams per mole. Okay. So then, to get from moles, let me check it one more time, make sure I'm doing the right thing. To get from moles and change it to grams, I'm just going to take the number of moles and multiply by my mole mass. So we're going to go 0.025 times 74. That's an answer. What do you get? 1.85. So we're going to say 1.85 grams. Okay? That's about as tricky as they're going to get. Does anybody have any questions? let's shift gears a little bit and let's look at the bottom half of this page. Bottom half of this page is talking about dilution. Remember, a dilution is where you're going to take a concentrated solution, you're going to add more solvent to where it's less concentrated. And you use this formula right here, M1 times V1 equals M2 times V2, and again, just to refresh you, M is going to be concentration. Okay, molar concentration. V is going to be volume. Now, the nice thing about this is that it really doesn't matter what unit your volume's in. Your volume could be in liters, it could be in milliliters, it could be in gallons. It really doesn't matter. Because what's happening is that your higher concentration times your smaller volume is going to equal a lower concentration times a larger volume. Okay? They're sort of inversely proportional to each other. So let's take a look at a couple of examples. Look at 13. Determine the final volume of this solution. If 4 liters are 4.67 molar, Li2SO3 is diluted to make 3.89 molar. That's lithium sulfite. So let's see. So if it's M1V1 equals M2V2. Let's see what they give us here. What is M1 starting concentration?
4.67.
4.67. Good. 4.67 molar. Okay. What's M2? What's our final molarity?
3.89.
3.89. Good. Okay. V1 they give us is 4 liters. And V2, we don't know yet. So, you can do a couple things here, and I don't know why I have to keep selling this to people, but a lot of people want to just start plugging numbers in now and then solve. I find it easier to solve before I plug in numbers, okay? Because I only have to do one set of things in my calculator. So if I'm trying to get V2 by itself, how do I change this formula to make that happen? I'll do this one.
M2 to the other side.
How do I get M2 to the other side?
You divide it.
I divide both sides by M2, right? So M1 V1 over M2 is going to equal M2 V2 over M2. If I divide the same by both sides, cancels over here. So then now all I have to do is take M1, which is 4.67, times V1, which is 4, and divide by 3.89, which is my M2. What do you get? That's what I get to, so I'm going to say 4.80. What's my units, by the way, since I'm talking volume too?
Liters.
Good job. So let's common sense check this and see if it makes sense, okay? So I'm starting off with a higher concentration and a lower volume. I'm ending up with a lower concentration and a higher volume, so it does check out, okay? Questions on that one? Does it get much tougher than that? Little. Not too bad though. Okay. Look at 15. Question? Okay. What is the initial concentrated molarity of 250 milliliters of KBr solution if, when diluted, it made 8 liters of 1.5 molar KBr solution? So, I see a few pitfalls here. Let's start by saying about defining our variables. Okay? So it wants to know initial concentrated molarity. So we don't know M1. Okay? 250 milliliters of KBR solution. What's that going to be? One or two? Okay, I agree. 250 milliliters. Okay? And it says when it's diluted, it makes 8 liters. So 8 liters is going to be our V2. And so M2 is 1.5 molar. So who sees a problem before we go any further?
You got two different, you got milliliters and you got
Right. So I can either make this 8,000 milliliters or I can make that 0.25 liters.
0.25.
I like that one better myself. Okay. Good. I said it doesn't matter what the unit is, but you do need to make sure they're the same unit for both before and after. Okay. So if I'm solving for M1, M1V1 equals M2V2. If I want to isolate M1, I'll divide both sides by V1, so it becomes M1 equals M2 V2 over V1. And I can just plug in my numbers right off that. So that's going to be 1.5 times 8 divided by 0.25. I'm thinking we're going to get a very large number for our answer by comparison.
$48.
Okay. I'm getting 48. And what's my unit going to be?
And
Molar. Okay. Which makes sense because I am diluting this a lot. I'm diluting it to about 32 times bigger than it was. So my concentration should be about 1/32 of what it started out with. Okay. Let's look at one more together, and then I'll give you guys a little bit of practice. See what you figure out. Let's go down to 18. Okay. NaOH, sodium hydroxide, is commonly called lye. Cool personal story about this. My wife got bored a few years ago and decided she was going to try and make soap because she didn't like any of the soap that they were selling at the store. So she goes to the hardware store and she buys industrial strength drain cleaner, which is 100% sodium hydroxide. This is the stuff that you put in your drains when nothing else works because it will literally eat through oil, fat, skin, hair, fingernails, anything organic. It will dissolve. And she took this and she put it into a crock pot with some, I think, olive oil. You could use any kind of oil or fat. You could use bacon fat, whatever. Heated it up and stirred it for forever, and she made soap. Because my wife is a boss. Okay, it was really good soap too. She may or may not have ruined a couple of crock pots over the years and were, made a mess in her oven, but she always wore her goggles and her apron and her gloves. She's an English teacher, by the way. But she's still pretty awesome. Anyway, I'm in, nobody cares. So it's commonly called lye. If you dissolve 450 grams of sodium hydroxide in 1 liter of water, you make a concentrated solution. So how much 2 molar solution can you then dissolve the concentrated solution into? My goodness, there's a lot to unpack here, right? Okay, so we're assuming at some point we're going to get to M1, M2, V1, and V2. What do they give us here? They give us 450 grams of NaOH. So one thing we're going to need to do is we're going to need to convert that into moles. Okay, but they're nice enough to tell us that it's in 1 liter of water. So let's go ahead and say that that's going to, for all intents and purposes, we're going to say that V1 is going to be 1 liter. Okay, I'm trying to dilute it into 2 molar solution, so M2 at least is going to be 2 molar. V2 is how much, and so that's going to be what we're trying to solve for at the end. So I need to change grams to moles. If I have my football, I'm going to start folding from the right hand side this time. And if I'm given grams of substance A, and I want to find moles of A, then in this case, going from grams to moles, I'm going to divide by that mole mass. Okay? Same substance, I'm not having to involve any mole ratios, I'm just changing A from grams to moles. So, let's do that. I guess that means we need to find the mole mass of NaOH. Sodium, if you look there, is 22.99, so let's call that 23. Oxygen 16. Hydrogen 1. So that's 24 plus 16, let's say 40 grams per mole. Give or take some decimals. So let's take this mass that I'm given, since I have to take grams divided by mole mass to get moles. So I'm going to take 450 divided by 40. It's going to be what, 11.25? 11.25? Okay, 11.25 moles. Now, to get molar concentration, I do that divided by liters of solution. So 11.25 divided by 1 liter. Hard math.
11.25.
There you go. So we're talking 11.25 molar. Okay, now we can do our wizardry with our formula. If we're trying to get V2 by itself, that means we're going to divide both sides by M2. So it's going to be M1, V1 over M2. Okay. And we can plug our stuff in. So that's going to be 11.25 times 1 divided by 2. 11.25 over 2. I get 5.625. And since we're looking for volume, that's going to be 5.625 liters. Okay? So again, that is about as tricky as it's going to get. Are there any questions about anything at any step of the process here? Okay. So it seems like we've still got a few left over here. See, we didn't do number 17. We didn't do number 5 or 7. So I'm going to tell you what. I'm going to have you work number 17. And do you want to work 5 or do you want to work 7? Either way, you're going to have to convert grams to moles. Do you want to do it with NaCl or with Na2CO2?
Probably NaCl.
Okay, y'all agree? So you would like to work number 5 and number 17? Okay. Then I'm going to leave you to work number 5 and number 17. And knowing that you've got to go from grams to moles, you're going to be using your football like this. So work with the people at your table.